All right, let's get started. Welcome to the session on Towards an Evolutionary Architecture and Design. My name is Venkat Subramaniam. We're going to talk about a couple of different things. I'm going to talk about three things. Talk a little bit about architecture, talk about the risk of not evolving architecture, and then we'll talk about the risk of evolving architecture, and then we'll talk about how to actually approach that. Best time to ask questions or make comments is when you have it, so please don't wait till the end. Anytime is a great time. So let's get started. Well, I want to talk about, first of all, with a question, leading question, what is architecture? That's the first right answer I get every single time. So what you just said is, architecture is something I can feel, but I can't put into words. So that happens a lot, right? Excellent. Let's try the second definition. What do you think is architecture? No, it cannot be the same as the first definition. It's got to be different. What do you think? Fair enough, right? It's a shape of the major structure of a system. So, in other words, we're looking at topology, right? And how things are related to each other. So you could say an architecture is a view of a system, and a couple of things to kind of dive into this. One of the articles that I often ask people to read, if you haven't had a chance to look at it, this is one of my most favorite articles. It's by Martin Fowler. If you Google for it, it's called Who Needs an Architect? And I won't really talk about this. I don't want to spoil the thrill for you to read and share with your team. But this is an article by Martin Fowler. If you just Google for it, you will see it. But in that, he talks about the role of an architect and various other things. But one of the interesting things in that article is he talks about a definition that Ralph Johnson gives about architecture. Now, one of the things we normally say is, an architecture is something that's hard to change. Well, unfortunately, I don't like the definition. If architecture is hard to change, we can make anything that's hard to change and say we create an architecture. But I want something a little better than that. So they also say an architecture is a shared understanding of the important details of a system. I like that a lot better. It's a shared understanding, meaning it's not something that is exclusively for some people. It should be available and understood by the entire team of important things in a system. And we can think of an architecture as just that, important details in a system. But there's a problem though with architecture. We are working in projects where in agile development, we are saying we should evolve architecture. But let's think about where we were, what we have done in the past. Well, in the past, we did waterfall development. And what did we do in waterfall? We designed the heck out of systems. And then when we were done with designing systems, we started coding. And that was a disaster. Because the minute we started actually coding is when we really started realizing what works and what doesn't work. And it was often too late to make the change to it. So doing a big upfront design did not really work well at all for us. And so what are we going to do? Well, the good news is now we are all doing agile, which means no design. This is awesome, right? And this is like the inmates are running the asylum and there's no control of anything. And I think both of those extremes are very dangerous. Doing all the design we can and not doing any at all. So what we really need is a happy middle ground. Something that we can reasonably do. So let's look at the word big upfront design. The bad word here is not the word design. Not even the word big or upfront, or it's not even the word upfront. The word here is the word big. What if we can replace this with enough upfront design? So we can do enough design based on what we know and have the courage and the wisdom to postpone things we can postpone to a later time. So that is essentially something we should do in development, is to postpone things and do enough of what we can do based on what we know right now. Now, when it comes to design and evolving the design, we want to talk about why should we evolve the design. And one of the reasons for that is we are not able to really understand all the details about systems. If you really closely watch terms we have been using in our field, somebody would ask you, we are going to capture the requirements. The word capture tells you it's elusive, like the bunny in the backyard, and you got to capture it. Or we say, we're going to gather the requirements. Because it's all scattered on the floor, we got to gather it. So these things tell us that we are not able to get a really good requirements in the first place. But unfortunately, software has one thing called an observer effect. And what that means is, the minute you observe a piece of software, you want to change it. And that is something that happens all the time, no matter how hard you try to get the requirements. In fact, I'm going to say, if you want to build what your customers wanted, you will fail. And instead, you need to build what your customers still want. So this is a bit of a magic, isn't it? You need to build what your customers are going to still want, and so you need to get them to tell you what they wanted, but end up delivering what they still want. And if you look at Agile Manifesto, one of the things they talk about in there is to build working software. Now, they had good intentions. They just forgot to put another word in there. I don't want to build working software. You know why? Because half the programmers in the world can build working software, but it doesn't do anything useful. And I really want to build not just working software, I want to build relevant working software. So I want to build software that actually serves the customers, does something useful for them. But to know that something is relevant takes a lot more effort, and we have to interact with them to figure this out. So as a result, we definitely want to evolve the architecture. However, let's step back for a second and think about it. If I ask you, is architecture important? What are you going to say? Yes, of course. How important is it? A little important, or it's so very important? What do you think? He's a consultant, right? He says depends. Okay. So, what do you think? Is it important? Absolutely, right? It is important. You better not mess it up. Okay, leave the thought aside for a minute. Can we agree that if you're starting on a software project, would you say on a timeline, would we agree we want to develop an architecture? When do we typically create an architecture? Yeah, in the beginning. Sometimes way in the beginning. I had a client, they came to me and said, we want you to work on a project. It's very important to us, but we got some requirements, very strong architectural constraints. What is it? They said, it's got to run on the cloud and it has to support concurrency. I said, tell me that again. It's got to support concurrency. It has to be on the cloud. Cool. What does this project do? They said, we don't know yet. But it's got to support concurrency. It's got to be on the cloud, right? So sometimes we put the architecture way in the beginning and we decide all of this and then come back to figure out what it's all about. So we can agree that's when we create the architecture, right in the beginning. But can we also agree that on a software project, typically, this is the curve of knowledge. In the beginning, you don't have a clue. You may think that you do, but you don't, right? And about 40 to 50% into the project, things begin to make sense. Towards the end, of course, no problem at all, right? You've heard about RAD, right? RAD. Anybody can tell me what RAD is? Rapid Application Development. That's what I thought until I ran into one of my bosses. He said RAD stands for Requirements After Delivery. Right? You can never be wrong about it, right? So a lot of times we wait until the end to figure this out. And then we say, that's what this project is supposed to do. Now, if this is the curve of knowledge, what we just said is the following. Architecture is so important, you better not get it wrong, and you're going to do it when you don't have a clue what you're doing. So fundamentally, This is completely irrational. So this by definition leads to a high risk already. So what if rather than developing the architecture in the beginning, and we're not saying don't have a vision, we're not saying don't think about it, but don't commit to the details at this point. What if you can evolve the architecture over the next, first few sprints before you get to commit to some details? So in fact, that is something that requires a bit of a courage. Now, what is the courage? Where does the courage play a role here? If you are hired as an architect, now I'll tell you honestly, the term that I hate the most in any company is an architect. Because if somebody comes to me and says they introduce themselves as architect, I try to stay away from them. And I really hate the term architect. When I was talking at a conference, I had my good friend Glenn Madberg with me, and somebody asked, what about an architect? And I blurted out immediately saying, I really hate architects. And as I was finishing up what I was saying, is when I realized Glenn actually was a chief architect in a company. I immediately took several steps away in case he throws a punch. And he said, I'm an architect, and I also hate the term architect. And the reason I really don't like the term architect is not because architects are bad people, not at all. It's because it's come to mean architect really means I don't code anymore. And these kinds of architects, I have a special name for them. Those people are called PowerPoint architects. And these people are very dangerous because they draw a very nice PowerPoint. And by the time they are done with it and they leave, nothing ever works in systems. And the rest of the team works together to clean up the mess they created. And I don't want PowerPoint architects. I want architects who are relevant and who can really lead the team by mentoring the team rather than drawing pictures. So given that, we definitely want to evolve the architecture, and we want architects to play a role into this, absolutely. But how do we really evolve architecture? Well, there is a risk here in not evolving the architecture. There are two risks, at least, in not evolving architecture. The first risk is, if you decide on the architecture in the beginning, I was talking about why do people design on architecture in the beginning. If you get hired as an architect, what does your company say? We hired you, we want you to deliver an architecture. If you go to them and say, yeah, thanks for hiring, but I'm not going to give you an architecture. We're going to wait for this. Well, that requires enormous courage to stand up and say, that's what I'm going to do. It takes courage to say, here's a draft of the architecture. We can think of architecture, but we cannot commit to it. That takes courage in organizations to be able to do that. But a lot of people want to deliver architecture and not evolve it. But what is the risk? If you develop the architecture really quickly, there are two problems with it. One is the question of relevance. Now, it turns out the architecture is not relevant. And when it is not relevant, what happens? Well, we are trying to really get the system to work based on the needs we have, and an architecture has been developed, and now you cannot say, we're going to abandon this architecture. We're going to go do something else. I mean, they're going to be after you. We hired you to create an architecture. Why are you not implementing it? So when that happens, what really happens in teams? The question of relevance. The second problem is governance. And there is a governance, and there is usually in companies, there's an architectural committee. You probably work for one of those companies where you cannot just make your decisions, you got to submit your ideas to architectural committees. I figured this out over the years. Architecture committee is where innovation goes to die. Because you got this great idea, you submit this proposal, by the time they come back, it's obsolete, and nobody cares about it. So governance becomes a lot of a problem as well. The organization has to change in a fairly reasonable way. On one hand, you want governance. On the other hand, you don't want governance to turn into stagnation. There's a big difference. Are you governing or are you stagnating is a good question to often ask. When it comes to relevance, there are two problems again. If you are architecting a system and it no longer is relevant, there are two problems with it. The first problem is the team is held hostage by the architects. And the architects say, you will develop this because we architected it. So what does the team do? They shrug and say, fine, you want it, you got it. And they develop this and deliver it, and no longer is the system relevant to the problem on hand, and it becomes expensive to change the system over time. Or, a lot of teams, something a little different happens as well. Remember, the architect doesn't code. So the team is very smart. They quietly nod, and they don't say a thing. When the architect shows up, they point to the diagrams on the wall. The system does one thing, and the architect has done something completely different. And in this case, they kind of go under deliver a working system, which no longer resembles the architecture. In both cases, the architecture didn't serve any good purpose. So we definitely want to evolve architecture. Not evolving architecture is risky. But let's not be naive about it. Evolving an architecture has risk as well. We cannot say, evolve it and everything is just fine. There is a risk in evolving architecture. What are the risks in evolving architecture? The first risk in evolving architecture is the what if we can't support. So what if we can't support a feature? Now this is one big thing we all are fearful of. So you're in the 7th sprint, a particular feature is being requested, and you realize to implement this feature, you got to completely rework your architecture. And you are fearful, hey, what do I do in this case? Because my architecture has been evolving, we didn't think about it, now we are completely throwing it out and redoing it, it's very expensive. For this, I'm going to talk about two kinds of features. I'm going to talk about a planned feature, and I'm going to talk about a surprise feature. Let's talk about both of these, what these things mean. Let's talk about a planned feature. A planned feature is things you know that you're going to work on. In the beginning of the project, you drew up a project backlog. You got a list of stuff that's given to you. One requirement, for example, says you must be able to support 3 different kinds of payment option by clients. Well, that's something you knew it's coming. So what do you do when you know these things are in your project backlog? One of the places where teams go wrong is they take the user stories and then just they split it across and say, here are the stories, we're going to implement these sprints, and then they act surprised when the sprint comes along. The first thing I would recommend doing is you take a story. So story 1, story 2, story 3, story 4, and all the way down to story n. The first thing I would like to do is I want to take each of the stories, and this is again like any estimate, but better to do than not do it. I would ask the first question, what is the business value of this story? The second thing I would ask is, what is the architectural impact of this story? So if I can understand the business value and the architectural impact, this is very important and it's got a lot of impact on it. This one is not as important, it's got a very less impact on the architecture. This one is extremely important but has a medium impact on architecture. If you can start putting business value and architectural impact, then we can prioritize the story based on the architectural impact and the business value. The ones that you work in the beginning are the high value and the high impact. Now there's a problem here. If you take on high value and high impact, you're going to go a little slow in the beginning. Here is another misguided initiatives a lot of companies have. They worry about velocity. Velocity is foolishness, because if you think of velocity, if I want to show you really good velocity, I will take on stuff that's of absolutely no use, and I can show you how quick and fast I am. The time velocity is the most important is towards the end of the release, not in the beginning. I don't want you to be really fast now. I want to be really fast in the end when things have to be really released. So don't give me a great velocity now and come to a grinding halt towards the end. So if you take on hard things first, your velocity is going to be slow, and then you improve on it as time goes on. So take on the most valuable and the most impactful things first, and then the easy ones later on. This has 2 benefits. The first benefit is you're taking on the hard problems first, which means the risk is going to become less as time goes on. If it's a planned feature, in the 7th sprint, whatever you have done in the past is more important than what you're going to do now, which means I can compromise more on this because what I've already done is much more important. And so the risk of this surprising you is a lot less. Second, if you have features coming ahead, you don't take a particular sprint and say, let's do sprint planning on the first day of the sprint. This is another misguided notion. Because you tell the team, don't ask me questions, don't think we are agile. It doesn't make any sense. So you got to do a little bit of a pre-planning. So I would take a sprint and say, maybe a sprint and a half before the sprint, I will look through the features, look through these stories and say, what are the unknowns? And if there's a really major unknown coming 3 sprints from now, I would start implementing a spiking session right now so I can convert some of the unknowns to knowns so I can do better estimation, better planning as well. So we have to constantly look ahead a little bit, not way too ahead, but you got to look a little bit ahead as well in these development. So we can take care of the planned features by prioritizing the stories and working on it, and that can mitigate the risk. What about the surprise features? Surprise features are features you never planned for. However, your marketing folks or business people go to this conference and they get to know that a competition is working on a feature. And they frantically call from the conference telling you the world is falling apart. If they don't have that feature, there is no way to even do anything anymore. You got to do it. Keep in mind about one thing. Surprise features don't come to you and ask you, are you waterfall or are you evolutionary? It doesn't say, you guys are waterfall, I will not surprise you. You guys here are evolutionary, I'm going to surprise the heck out of you. Well, surprise happens no matter what. It doesn't matter what kind of implementation you make. However, I'm going to argue, if you did a fairly good evolutionary design, you're not going to just do evolutionary and say we are done. There are certain things you're going to do. One of them is keeping things minimal. If you kept things minimal, it's easier to change what is minimum than change what's a monster. So one of the things we do in evolutionary design is to keep things minimum so it is actually not too hard to incorporate a change, and we are at a better shape to take care of the surprise features at the time than we are in a traditional waterfall or big design and architecture phase. So we talked about the design, the risk and how to handle them, and we talked about prioritizing based on the business value and the architectural impact, and we talked about some of those things. I want to shift gears to how. How can we develop evolutionary architecture and a design? The very first thing I want to start out is keep it simple. Well, it's easy to say this, but a lot of times we don't even know what simple really means. And simple is something we all agree, but on a given problem, we can't pinpoint and say that's simple or not. So what is simple? I'm going to say simple is something that is easier to understand. Simple is something that is easier to change. Simple is something that has fewer moving parts in it. Simple is something that fails less, but when it fails gracefully. So we want to really build things that are simple. But unfortunately though, at times we don't know what simple is. It reminds me of an experience. I was working with a few developers, and I was complaining endlessly that their code is complex. And one of the developers finally said, I don't understand why you're so complaining about this. We think this is a simple design. And I said, how could you say this is simple? And they said, look at the code. It's a simple if-else statement. And that's when I realized they did not understand what simple means. Because the simple if-else statement was repeated 60 times in the code. And every time you came to make a change, it was expensive. So sometimes we don't realize what simple really means, and we get really stuck on it. So we often say we want to make a design simple. One way to make a design simple is don't solve a problem you don't understand. Second, don't solve a problem that doesn't deserve solving. Now, this is one thing we all do as programmers. We take pride in solving problems. And to do so, sometimes we create problems and then we solve it. Instead, we should ask ourselves, is this a problem worth solving in the first place? So we want to definitely keep it simple. Second thing we can do is we need to refactor continuously. And I'm going to go to a further and say about 50 to 60% of the time you want to refactor, but other times you really need to have the courage to rewrite. And when it comes to rewriting versus refactoring, I want to draw a line, a distinction. I would like to refactor other people's code, but I want to rewrite my code. And the reason I say this is, sometimes we have a bias. I don't like this other person's code, I got to rewrite it. We should avoid that urge. Best code to be rewritten is our own code, otherwise refactor it. And the reason I say this is, sometimes refactoring is a good idea, but sometimes the code is messed up beyond reasonable repair. The best thing for you is to destroy it and start over. Now, Frederick Brooks said something wonderful, and he wrote this 30 years ago, maybe 40 years ago, and we have been working very hard. So if you ask me, what is software development? I figured this out now. So here's what software development is. Software development is, dev is a human activity where we continuously try to disprove Brooks. So this is what we've been doing very hard. What does the old man know? He said all this, I don't believe it. And we go through this over and over and over. And Brooks said, way back in time, he said, go ahead and develop a software. When you're done with it, throw it away. And start over, you have a chance. Now, be careful. This is the best way to get fired. You go to the boss and say, boss, I've got a great idea to improve software development. What is it? We'll finish this project, and when we are done, we won't release it. We'll delete it and start over. Well, that doesn't make any sense, is it? Well, does it mean that Brooks is wrong? Well, it cannot be. He has said really good things. So there seems to be a conflict. How could it be right and wrong at the same time then? Because I can't delete my software and start over. Wait a minute. You don't have to delete your entire software. What if you start deleting every small piece of code you start creating and then rebuild it? What if you don't delete your entire software, but you delete these 3 unit tests and start over? What if you delete this one package and start over? I'll give you an example of this. I was on a long flight. It was about a good 16-hour flight. And when I started the flight, I told myself, I'm going to implement a fairly complex feature in the product I was working on. So I got on the flight, and I had this wonderful 16 hours on the flight. I do a lot of work usually on the flight, so I said, this is great. I'm going to work on this piece of code. And I trust me, no other in-flight entertainment can ever come close to working on a piece of code, especially your own code, right? I'm sitting there and working on this code, and at the end of the flight, I was done. And when I finished it, I looked at my code and I said, this code sucks. And I did not like it at all. There are so many ways this code could be done better. So I go to the airport. From the airport, I go to the hotel. And remember, this is the end of the 16-hour flight. I'm sitting in my hotel, jet-lagged in the wee hours of the morning, and there was a battle in my mind. A part of my mind says, I dare you, Venkat, delete it. And the other part is like, are you crazy? You took the entire flight to write this, hold on. And after a few minutes of this battle, I quietly deleted it. And it was such a relief. It's like, wow, that crazy stuff is gone. It only took me, seriously, 2 hours to rewrite it, which is surprising sometimes, right? Because you had to go through the start process, figure out the details, go through the unknowns, but all that is in the head. And rewriting it was a lot easier. And when I got it done, it was a lot better than what I had before. I won't say it is perfect, but it's a lot better than it was. And to have this courage to delete code and start over is something we need to really have. And a lot of times what stops us from doing it is our own fear. Is our own, pride that says, you can't delete now, keep it. So delete the code and start over. In other cases, go ahead and refactor the code. And refactoring is absolutely essential. Because no matter how hard we try, we learn a better way to do this, and we have to constantly improve it. And so refactoring has to be a very healthy activity that happens along the way. When it comes to developing software, we have to ask the question, is this decision reversible? This is one of the most important things we need to ask ourselves. What is reversibility? Reversibility is our ability to back out of design decisions. Certain things are reversible. Certain things are incredibly difficult to reverse. If I come to you and say, don't bother, change your language on your software system, you're going to laugh at me because languages are not so reversible. And it is very expensive to make language reversible. I wouldn't even dare. Some companies have tried it. They say, we want to be able to change languages anytime you want to. And you're scared and you ask them, how'd you guys do it? We wrote our own. Now there are two problems. So the point is, you have to accept certain things are not reversible. But there are other things that are reversible. Like for example, I don't want to use this particular database. I want to use a different database. That's got to be a reversible decision. I don't want to use this XML parser. I want to use something else. It's got to be reversible. But just because something is reversible, don't assume it actually is reversible. Here's an example. I worked on a project where we were using an object-oriented database. And everything worked fine until one morning we got the news that the object-oriented database vendor completely changed their object hierarchy. And we looked at our system, and our estimate at that time was we have to spend 8 months changing code just to go to the next version of the database. When the company knew this, they were so angry, they said, why wouldn't we fire you all? Well, they couldn't because nobody else would work on this. And so it took 8 months to change the code. And I learned my lesson. I looked back and I said, why did this go so wrong? And there was only one reason I can point to, and that's called coupling. The more you are coupled to a system, the more it is difficult to reverse out of the decision. So if something is important for you that you have to reverse out of a decision, you want to really reduce coupling. A level of indirection maybe you want to use. But the point really in this case is, when you take on a decision, you ask the question, is this reversible? If it is reversible, and if you're going to design and implement in a way it's reversible, don't be afraid of making the decision. It's easy to change it when you have to. If a decision is not reversible, try your best to postpone that decision. Because if it is expensive to change, you want to wait before you make the change. Commit to that particular solution. Because once you commit to it, you cannot change it so easily. So what is reversible, you can make a decision easily and early. What's not reversible, postpone until you no longer can postpone it. And every decision you make, ask the question, is this reversible? Well, keep in mind, there's a cost for reversibility. It's not cheap. You're going to implement your design differently if you want reversibility. And the cost must be far less than the benefit you get out of the reversibility. If the cost is more than the benefit you get, there's no point affording for this reversibility. So that's a very important decision we have to ask ourselves. Is this reversible? Is it worth reversing? That's something we have to ask constantly. So when you design software, keep it simple, actively refactor and rewrite it, and then ask yourselves, are your decisions reversible, and plan for reversibility. And I'll give you an example of this. I gave one example of the database system. But here is another example. I was working on a software where my customers told me, I have to use a particular package. I've never heard of this package. I don't know what this package really provides, but their contract said you will use that particular package. So I wanted to really accommodate it, but I had this nervous feeling, what if it doesn't really do the job properly? So I planned for reversibility. I provided an alternate solution while we waited for getting this particular third-party product and learning about it. But along the way, when I got the third-party product and started playing with it, and I quickly found out that this is not going to do the job. It was going to be really poor in performance and various other problems. So the way I handled this was to develop a prototype. And developing this prototype quickly gave us an insight, and I was able to explain to the customers why this may not be a really good idea. And once we realized this is not a good solution, we backed out of that and started using something else. So not committing to something early on is actually a good idea, and you want to really wait for that to mature. That brings us to what's called the last responsible moment. Last responsible moment is when you are going to postpone a decision until you no longer can postpone it. Don't confuse last responsible moment with procrastination. Procrastination is not making a decision that should have been made last week. Last responsible moment is you either make the decision now, and if you don't, you begin to procrastinate. So last responsible moment is extremely important in software development. Now, why should I really wait for a last responsible moment? The answer is very short. The two main reasons. You're smarter tomorrow than you are today. So when you make a decision tomorrow, you can make a better decision than you can make today. That's one thing. Second and more important reason, if I don't make the decision now, I can go faster focusing on other decisions that have to be done now, and so you want to postpone things so it gives you focus. I'll give you an example of this. I was developing a software system, and I had exactly 6 months on my calendar. From the date of starting the development to the date it goes into production was 6 exact months. I didn't have the luxury of postponing it. So when I started the project on the first week, you cannot imagine developing an application without a database. So the first thing I would need is a database. In this case, I wanted a relational database. So first thing is bring on a relational database. And I realized if I bring in a relational database, there are two problems I'm going to run into. My test, I have to work with the relational database to clean it up quite often. Second, one thing I knew clearly is I don't know a lot. My database schema is going to change constantly. My database schema is going to change constantly as in hours, not in days and weeks. And here's the problem. Changing the database schema on a relational database is not the most pleasant thing to do. And I asked myself, am I better off with a relational database or better off without it right now? And clearly everybody here can agree, nobody in the right mind would ever put a product in production with a SQLite database. But guess what? I love SQLite for one reason. It's a file. You delete the file, your database is gone. You don't have a database management system. There is no process. There is no daemon. It's a library. It's a driver. You talk to it, it talks to the file. If the file doesn't exist, you create one. So I made this clear decision that I'm going to use SQLite until I no longer can postpone that decision. Was I worried? I was worried really bad. But I told myself, don't worry, Venkat. And I kept on coding with SQLite. How long? Remember, this was a 6 months project. And every few weeks, I would remember about this database not being in place. It would worry me sick. Then I would listen to music and forget all about it, continue to code. It went so beautifully until I was at the beginning of the 5th month. Now you may say, oh my gosh, you spent 5 months programming this. Why did you not pick a database? There are two reasons. One, I didn't want to, because I want to postpone this because coding is so much fun, easier when you don't have a database to deal with, real database to deal with. But the other reason is, I have to deploy this product on the cloud. and I did not know what cloud service I was going to use. And different cloud services I came to know offer different pricing for different databases. And once I know what cloud service I'm going to use, I wanted to pick the database after that. And at the end of the 5th month, I got exactly 1 month to go before I deploy the product. And one morning I came to work and I said, I'm in trouble. Because I don't have a database at all, and I know what cloud service I'm going to deploy. If I don't do this now, I'm in denial. So I remember this morning, I came to work, and I told everybody, don't talk to me. I've got important stuff to do. I turned off the phone and sat there and I said, today is the day to switch over to the real database management system. So I went in there, I modified the configuration file, pointed to the real database system I was going to use, download the drivers, install the daemon, everything is running on my machine, and I said, I am ready. And of course, I was very nervous. What if something is going to go wrong? I ran all my tests, and 3 tests immediately broke. That moment is called the moment of panic. I'm like, I want my mom. Right? It's like, gosh, what do I do? It's broken. And I have to tell myself, Venkat, calm down. It's okay. Let's figure out what's going on. I'm not kidding with you. The error is on the display. I highlighted the first error, pasted it on Google search. The first link was Stack Overflow. It said, if you see this error, it means your data format is wrong. I'm still in panic, but God, please help me. And I'm sitting there changing the data format from a var to whatever it is. Roll back to my old database and run all the tests with the change, all the tests passing, put back the configuration, run all the tests with the new database management system, all the tests passing, check in, last day I ever used SQLite on this project. But notice one thing I did not do. I did not run the application to see if this is going to work. Now let's revisit for a minute. You go to a team and say, I want you to postpone a decision to the last responsible moment. And they look at you and say, like how long? How about 2 weeks before deployment? They will say, are you crazy? Now why do they say this? Because there's one thing that happens when you decide early on. You can test the heck out of the system when this happens. And if it works for 5 months, 6 months. If it doesn't work, it's not your fault, it's the tester's fault. So, in other words, when we say we want last responsible moment, I realized on this project why people don't want to do last responsible moment. It is because they don't have a fast feedback loop. When you don't have a fast feedback loop, you make a decision 2 weeks before you go into production. Now you got to manually test every piece of your software. Nobody in the right mind would commit to that. So in other words, if you want to rely on last responsible moment, you also have to design and architect your system to have a fairly good automated feedback loops. If you don't have automated feedback loops, if you rely predominantly on manual testing, it's almost impossible to apply some of these things. So that's one of the reasons why I value a very thorough automated testing. So on this particular project, I ran my automated test. They broke. I modified the code. All the automated tests passed. I deploy it, and I don't have to think about it again. So these days, the only time I manually run a program is if I actually modify the UI. If I don't modify the UI, I actually don't make any effort to run the program at all. About 2-3 weeks ago, I made a very critical change to my business. I had to make a change to one of my computations on the back end, which had to deal with financials. Now, honestly, I'll tell you, you can call people by names and they forgive you. You mess up their credit card payment, they will never ever forget you. And the point is, I'm making a change to a way I'm handling payment. I was pretty nervous, but I never ever ran the program to test it. All my automated tests are passing. I wrote new tests, they go up in flame. I fix the code, all the tests are passing, deploy, and move on. And there is no reason to manually test it. Why? Because the logic for this is not in the UI. So why am I going to test this? Why am I going to test it by running this manually? So to get really the ability to do last responsible moment, we really have to have a fairly good automated feedback loops. And without it, it's almost impossible. The next thing to think about when it comes to evolving design is the Yardeni Principle. The Yardeni Principle says you aren't going to need it. And you want to postpone decisions to the point where you don't have to implement it at all. To give you an example of the Yardeni Principle, I wanted to build this application, so I went to a few of my good confidants and I told them, I'm going to build this app. I've got this vision in my mind. I've had this in my mind for a few years. I finally gathered up courage to do this. Could you please take a look at this and see if this makes sense? And I sent a list of features to my friends and said, give me some input, give me some feedback. And they all came back with, yeah, this looks like a great idea. That one is not of value. Oh, you should really do this. All this good stuff. And once they came back, I said, thanks for your input. I'll get back to you when I have more. And I started developing the app. And after I finished it, I was about to deploy it. I went back to the same good friends and I said, hey guys, could you do me a favor? Here's the URL. Don't give this to anybody. I've deployed it, but the world doesn't know this yet. I'll announce it in a few days. But can you take a look at it? Give me your feedback. And so they did. And they said, you could improve this. You could do this better. I like this, whatever. But one of my buddies did something a little different. He came back and he said, aha, when you sent me the original list, I saved it away. And I went to the app now, looked at it, used it, and I started checking on the features list you had with the features that you have in production. And I realized you have about 40% of the features. What's up with that? I thought you're going to implement all of this, and 6 months later, you got a lot less. And my answer to him was, I don't need those features to start making revenue. Because what I have built so far, the 40%, is good enough to start making money, to start providing value. And the other features, I can come back and implement it. It's been about 5 years now. And I look at the features in the application. And there are 3 things I noticed in the 5 years. A, there are some features in the product that were never in the original list. These features were thoroughly implemented based on active feedback from users. Every couple of weeks, I would get an email from a customer saying, I'm using this, it would be so nice if you can provide this for me. You know what? Hey, here's a paying customer who wants a feature. Nothing can beat that. I would work on that weekend, push the feature and say, can you try this? There are features in the product today that were in the original list, but they were not in the original release. I did add some of them. There is also features in the original list that I have not cared to implement it even today after 5 years, and I may never actually implement it. And the reason simply, no one cares. Nobody seems to want it. Why waste your time doing it? So the point really is, oftentimes we force ourselves to take on way more than not only what we can do, we often take way more than what needs to be done as well. So postpone features and only implement what you think is absolutely necessary. And even in the features you are implementing, only implement parts of it that really are important. Sometimes we come up with the scenario where we start reporting bugs. Oh, this doesn't work. But who in the world is going to use this particular feature this way? Well, nobody. Then don't report a bug. Get rid of the code. So we need to have the courage to throw things out rather than implementing. In fact, a research study showed that in a typical enterprise application, about only 20% of the features users actually use. close to 60% of the features no one cares to use at all. And you may say, well, 60% of the feature nobody uses, but still, what's wrong with having it? Well, it's that code that makes it very hard for you to extend your software when a change has to happen. Because when you try to refactor and introduce a new feature, it's got to work with all those other code, even though those code is not being used. So one of the things we should really have the courage to do is not to just write code, but to remove code as well. I have a client of mine who has an application which is 30 years old. Literally, it's 30 years old. It's a cash cow. They called me and said, we got a problem with this application. I said, what's the problem? They said, the problem is this product is making money. If the product was not making money, it's easy, right? They can throw it away and walk over. But it's making a lot of money, which means they have to maintain it. And that's the problem. And they had difficulty with it, and eventually we decided they don't have unit tests, written 30 years ago, but they have tons and tons of integration tests. So all we did on this project was, we took all these integration tests and we added a code coverage facility to this code. So now when they run their integration test, it reports a code coverage. About 6 weeks later, one of the developers took the coverage, knowing the version control has all the code. He started hunting down code that's not being used and started removing it. For the first time in 30 years, their code base started reducing in size. And then they found out a year later, they're able to make change a lot faster now compared to before because they got a lot less code than they started out with. That's one of the things we should really try is to remove this. Of course, the question then is, what about extensibility? We all want to make software extensible. But the problem is, a lot of times it's hard for us to know what extensibility really means. What does it mean to be extensible? Well, here's the problem. If you want to make a code extensible, there are two things you would need. Knowledge. So the first thing you would need is knowledge of the domain. Because if you don't know what the domain is, how could you plan for extensibility in a domain you don't have a clue about? I used to work in chemical engineering. I'd go to my customers, my company, business analyst, and I would say, hey, would we want to accommodate this? And sometimes they would look at me and say, Venkat, if you ever do that, you'll be violating the law of physics and chemistry. I'm like, oh boy, I'm glad I asked you. I never want to do that, but I want to, right? Oh, I don't know anything about the domain. I just have to throw things and see if it sticks. Other times they would say, oh, great question. Oh, but that doesn't make any sense. That's only useful for hydrocarbons, not for other things. I don't know what that means, but thanks for letting me know. Other times they would say, brilliant question. We're so glad you asked. Still, I don't have a clue, but I'm so glad I asked. But the point is, without knowing a domain, I can't make a decision on that. There's another thing we need. Knowledge of software design and software concerns. If you don't do software development, it's really hard to know what extensibility means because you haven't planned for it. And somebody comes to you and says, hey, we want to do this. Well, we can't do that. Come on, it's a software. You should be able to do it soft, right? Well, sorry, that doesn't make any sense. And if you're not planned for it, it's not going to work. But here comes the challenge. If you look at your typical development environment, company, I can bet you there are three kinds of people in your company. The first kind of people, the type 1 people, these people have knowledge, so they have a really good knowledge of domain. But these people have no clue of software design. And I'm sure you have come across people like that, right? The second type of people, these people have no clue of the domain, but they have really good knowledge of the software. There's the third group of people, very small group. These are the people who have really good knowledge of the domain, but these people also have really good knowledge of the software. will politely ignore that fourth type. So given this, I would argue the people who can really make good decisions are this third category, because they understand the domain really well and they understand the software development constraints really well. But these are far and few in companies. Predominantly people are the type 1 and type 2. And the only way we can survive and make things useful is by collaborating. You need to, as a software developer, go to the domain experts and say, do we want to do this? And they in turn have to come and say, are we capable of handling this? So the collaboration becomes extremely important for us to be able to survive in this area because of the sheer complexity of things. So if you want to make software extensible, it's a collaborative effort. If you try to make software extensible for arbitrary things, the software becomes so complex that it's not going to really be able to extend it. In fact, Ralph Johnson said, we develop a hierarchy of classes, interfaces and implementations of classes. And why do we do this? We do this with a good intention to make the software extensible. And in doing so, we created such an amount of complexity that it becomes really hard to change the code when it comes to extending it. So what we set out to do better itself backfires on us most of the time, so we got to be very careful about it. So one way to take care of this would be to deal with what's called parsimony. Parsimony is where you go after absolute minimalism. And you don't bring in anything that you don't really need to bring in. You avoid doing things that you don't have to do. I don't need more classes. I don't need more methods. I don't need more XML. I don't need more flexibility than I need. This is something we all have to work really hard to do, because sometimes we build stuff we don't need and that becomes really hard to maintain the code. So in terms of parsimony, one of the things I've been struggling really hard is state. In object-oriented programming, we have built up so much state that every class becomes bloated. And for the past few years, I've been really working hard to design systems that have minimalistic state. And I would sit there and think critically and say, do I really need this variable? Can I pass the data around and get the computation done rather than storing this data? And there is so much we benefit from having this kind of parsimony. Sometimes we also have the urge to solve problems which really don't exist. And when that happens, we got a lot of solution that we put in for a problem we don't have, and that really slows us down, but it also makes it incredibly hard for us to maintain the software. So minimalism, parsimony is a good principle to follow as much as we can. For example, if I can get away by not using an extra library, if I can get away not using a few extra classes, if I can get away by not having to support a few more of external clients or features. And also to ask the question to the users, what do you really want? I have a very bitter experience actually in this area. The customers told me they need to produce a monthly report. And I got really excited. You want a report? I'm going to give you the mother of all reports. And I worked really hard and I produced this beautiful report. It was multi-page, PDF driven, with keywords you can search, and amazing. When I got it done, I was so confident that this is the best report, and I was waiting for my customers to call me and say, you are awesome. Well, the call came in eventually, and they said, we got a problem with the report. I'm like, what problem could you possibly have with the report? Do you not know where the key is to click on the button? Well, they said, we need to be able to extract the data into an Excel document. I said, you got to be kidding me. You don't want Excel? I've got this beautiful report. They said, you don't understand. Apparently not. What is that you need? Well, this application is part of a major workflow. And we got this report in Excel already. And all we care about is just that data going to the spreadsheet in Excel. I tried to tell them otherwise and finally realized that's what they really want. And you know what? It took me a lot of time and effort to do this beautiful PDF report. And I was angry because to produce this Excel report, it required changing the MIME type and splitting a comma separated value. I was so insulted that I have to actually write this code. And I wrote it, and a year or so later I went back and looked at it. That report, where it spits out Excel, is what they use constantly. And the PDF report, it was used exactly twice when I demoed it to them. Nobody ever touched it after that, right? So a lesson learned the hard way. We don't have to implement stuff we don't really need. Take the time to figure out what's actually needed. So at the feature level, at the class level, at the function level, how many times we do fancy error handling for stuff we can't even think of? And at some point we got to ask, will this ever happen? Is it even practical this happens? And we can reduce a lot of code for situations that would never happen. Why bother writing code for it? But what about extensibility again? If we really want to create base classes, shouldn't we be creating base classes? Well, one of the things to think about is, don't go around creating base classes. Instead, go ahead and create a class, class 1. Get the work done with the class. A few weeks or a few months goes by. You want something. Now here's the problem. We can sit down with a beautiful architecture and design, and what are we going to do in our paper? We're going to say interface 1, and then we're going to have a class that implements it. So class 1 implements interface, and class 2 implements that interface as well. And we can design this way. But then what do? Once we finish this design, we say, time to code, start writing the interface. Time out. Let's rethink about this problem. Let's implement just class 1, that's it. And your code is working with the class 1, and a few weeks or a few months goes by, you need class 2, go ahead and implement class 2. You say, wait a minute, if I do this, wouldn't there be duplication? Oh, yes, there would be. Isn't duplication bad? Only if others see it. So go ahead and duplicate it. Get that working. And the minute this works, you say, aha, I have an understanding of what this is about. And now that I have a better understanding, you are going to be very practical with this. Now extract the commonality between them into the interface from here on. So this is what Ken Beck calls as triangulation. So triangulation is where you implement one class, you implement the other class with a certain amount of duplication, and you triangulate by pulling the common stuff to the base. When you do this, you end up with a more practical hierarchy than we did without having these classes. So triangulation is a good approach to develop the system in a very lightweight manner. Well, okay, but what about communicating across systems? This is especially true with microservices world we live in. One of the problems with microservices is the services cannot be brittle. You cannot upgrade a service and the rest of the system comes crashing down. Now here's one thing that I don't understand. I have clients who come to me and say, we want to do microservices. They're so gleeful about it. And you say, cool. So what do you want to do? You want a microservice. Okay, we can do that. Where do you want to start? We want a shared database. This makes no sense. You have a shared database, you change the schema, the entire system comes down crippled. That's not microservice. So you have to rethink about how to design the system if you want to go towards these things, right? Well, one of the things to think about is called the Postel's law. So what does Postel's law say? Postel's law says, be very generous about what you receive and be very conservative about what you send. Let's think about this with a couple of different examples. I want to think about Postel's law. I got a service, and what does my service do? You're sending me an XML document. What do I do with the XML document? I'm going to parse it. I'm going to validate it. If the document is valid, I will go on further. If the document is invalid, I reject it. This sounds like a great idea in the beginning. Now I have an XML validator, a cop standing at the door, and what does it do? Hey you, I'm going to validate, and if you're good, I will send you, otherwise I will chop you right here. Well, everything works fine for about 3 months. After the 3rd month, he says, hey, I need an extra field in my document. He says, not a problem, I can send it to you. Well, you see, here's the sender, here's the receiver, I receive the same data, but I care less about this data that's been changed. Well, what's going to happen? XML document knocks on the door, and my validator says, I look at you, and you got something new. And the XML document smiles and says, isn't that cool? No, get out of here, right? And it gets thrown out. And now we put a few more months to evolve the code. Why? Because that change has to ripple through. And what are we doing? Just change a stupid validator. Now, of course, I'm not going to say JSON is really cool, but JSON is one way it's cool. It has no such business of validation. It's garbage in, garbage out, right? You send a data, hey, it smells like what I wanted. You want it? Great, I'm so happy to get it. What does JavaScript do if you send data that it doesn't know? JavaScript is so happy you're using it. It's willing to take anything you send, right? So as a result, it doesn't care. No validation businesses. So your system is by default a lot more extensible. So the point is, don't waste your time and effort validating part of your system that you don't care about. Be really generous about what you receive. So only check through and see if the data you're receiving is the data you really are caring about, and don't look at the other parts of the system. That's none of your business. If you don't couple to parts of the system you don't care about, your system doesn't fail and have to change when the parts of the system you don't care about begins to change. Let's talk about this at the interface level for a minute, at the code level for a minute. I've got a function called inventory, and the inventory says, I'm going to take an array list of book. Well, this code is going to suffer already, because he says, I don't have an array list, I'm going to send you a linked list. Oh, sorry dude, you can send me a linked list. Why don't you wrap it up into an array list and send me? And we're not friends anymore, right? We don't talk to each other, right? Look at him, he says, I don't like you. Well, we can change this a little bit better. We can say list a lot better than what we were a minute ago. Well, what's the good news? Hey, he's going to send me a linked list. He could send me an array list. Everything works fine until she comes along and says, I got a set with me. Oh, sorry, I can't get you a set. I want a list. Why don't you convert your set to a list? She says, I'll talk to you in the parking lot, right? That's not going to be really fun at all. Well, okay, how do we deal with this? Well, why don't we change this to a stream of book? Hey, look at the beauty of this. It's an iterator, and he could give me an array list, he could give me a linked list, she could send me a set. I don't care. I can handle all the three of them because all I'm getting from you is an iterator. That's Pascal's law at the interface level. So, in other words, any boundaries of your system, be very generous. Be very generous about what you will receive. Be very conservative about what you send. Obviously, when you're sending stuff, you're going to send one particular type so the receiver knows what you're sending and they can accommodate that very easily. So, given that holy grail in software development is reuse. How do I make the system reusable? Well, Grady Booth says, let's first make the system usable, then let's make it reusable. Well, the reason is, to make a piece of software reusable, it's got to be very generic. For it to be usable, it's got to be specific. It's a tension between the two. I'll give you an example of this. I worked in a company where they wanted to really create their module of software reusable. They found out that of their 120 products they have, every single product was implementing this logic, which is a very intense engineering logic. And when they realized it, they realized what a waste of money because a lot of people in the company are just solving the same problem. From the time the VP of R&D decided to make this reusable, to the day the company had a reusable module that worked across all these products, Take a wild guess, how much time? 12 years. It took them 12 years. Why? Well, they went to one product and said, you guys extract the module out. And they did. They went to the second project and said, now reuse it. And they're like, are you kidding? We don't like this convergence. We need a better convergence ratio here. Oh, that unit of measure you're supporting is not adequate. We want these transformations. That took them a few years. When they got it done, third product, start over again. And by the time all the products were done, and in the meantime, this library has to support performance for all the existing products. It cannot come down in performance or capability because you want this to be reusable, a very difficult problem to solve. The last thing I want to say here is something that is near and dear to me because this has pinched me quite a bit. Minimize libraries and framework. Programmers have this desire to use libraries. I was recently talking to a team. They told me their test doesn't work because they upgraded some JavaScript libraries and it doesn't work anymore. And I asked them in all earnesty, I said, how many JavaScript libraries are you using? The guy stared at me for a minute, swallowed a little bit and said, 150? I said, excuse me, on this one product, you're using 150 JavaScript libraries? Why? He said, because we found them. Right? So I'm true to the answer, right? We found these libraries, so we have to use it. This is called infatuation with technology. I'm not going to tell you the world was better 30 years ago. But 30 years ago, when I was a kid, when I was programming for companies, if I wanted to use a software, I got to go ask permission to buy it. You had to pay for software. And you had to wait for it to arrive. And when it arrived, I'm not kidding, I did this. When it arrived, you take the tape and put it in the tape machine. And you wind it. And you wait for the tape to install it. The third time you do it, you say, heck, I don't need any software. Today, you're sitting there coding, hey, how do I do this? Have you used this blah, 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 JS? Oh, cool. NPM install. Every machine carries the internet today because everything has been downloaded, right? And you come to work and say, I'm really unhappy. What happened? I haven't installed an NPM package today. So go write one, right? So we got this insane attitude of bringing things in. There are two things I want to emphasize here. One is, I was recently working with a piece of code and I wanted to do a little feature and I Googled for it. And every corner I turned said, install this library and write these 2 lines of code, then you're done. And I'm like, no. Because if I install this and do these 2 things, it'll work. But guess what's going to happen in 6 months? I want to upgrade my version of the language or the framework, but I can't. Why? Because this little tool is not compatible with it. And I'm going to sit and wait. And now I'm chasing compatibility issues. Do we do that? All the time. You go to companies and say, hey, why are you guys not using Java 8? Because our system sucks. What sucks about it? We got all these dependencies. Why do you have these dependencies? Don't ask me. Right? And so I asked myself, how much time do I need? I realized I could get this done in about 30 minutes. And I put a timeout. I said, timeout, 30 minutes. At the end of 30 minutes, if this doesn't work, use the library. And 30 minutes later, it worked. And I never used this library. And I've upgraded the system since and didn't have to worry about it. But here's one thing we need to be careful about. I worked in a company where we were developing software on a 6-month schedule. We were supposed to release in 6 months, very critical software. We needed people to work, so we were interviewing people. We couldn't find a really good person. This was 2004, when the economy was really bad. And we found finally one guy, amazing, very smart. And he had developed his own framework. The VP of the R&D came to me and he said, what do you think of this guy? I said, don't waste your time, go hire him. Best person we have seen. Yeah. But what do you think of the framework he has developed? I said, amazing framework. Never seen one like that. Hire him. What do you think of us using the framework? Whoa, wait a minute. Don't go there. Hire him, let him work on the project. Do not talk about the framework. Venkat, you saw what his demo was. Don't you think a persistent, fault tolerant, well, distributed persistence is awesome. I said you never use the word distributed and persistent in one sentence ever in front of me. Why are you saying this? He said, don't you think fault tolerant messaging is awesome? Word fault tolerant messaging. I never heard that from you. Why are you saying this? So all the features of the framework are the features of the product now. I said, don't do this. Just hire him, get the work done. 2 weeks later, he comes over, sits on my desk and says, I got good news. Hey, what's up? We hired him. I leaned on my chair and I said, I can't tell you how happy I am. I'm selfish. This guy is smart. I want to learn from him. I want to work with him. I can't be happier. Thank you for hiring him. Oh, by the way, we agreed as the hiring contract to use this framework. I said, good joke. Don't scare me like this. No, we did. Are you serious? Absolutely. Well, I just quit. Oh, I know you're going to do this, Venkat. Well, how long are you going to finish it? Oh, still 6 months. You know what? Good luck. Do it. By the way, if you have any other job, call me. I'll come and work with you. But this is not the project for me. I don't want to be the stumbling block telling you guys every day this is wrong. One of the very few days I actually showed up home on, ahead of time. I walk into home, my wife is like, hey, you're early. Yeah, I quit. Well, in that case, maybe you can help me with the dishes. So a week goes by, find another job, move on. A year and a half goes by. My phone rings. Hey, this is Venkat. All right, go ahead and say it. I'm sorry, say what? I told you so. They have spent an year and a half building the framework so it can do what the project could do. Guess what? It didn't have anything to do with it in the first place. And he said, can you come and work with us? I said, there's a reason I ran away. When I was a lot younger, I would have said yes. But now I want to work on systems that actually finish. Sorry, don't call me. And he did again 6 months later. And said, you don't have to work on this. Just come, look at it, write a report, you're done. And I went there. He took me to a room. There was a product sitting there. I looked at it and said, you guys finished it. I said, go ahead and run it. And I entered the data. I clicked on a button. 25 seconds later, plop, the result pops up. Oh my gosh. I said, yep. And I looked at the profiling. That one click created 1,763 objects. Very object oriented. And I said, where's the team? He said, we fired them all. So now we have a product with no team. I said, okay, and why did you call me here? He said, fix it. All right, I'm sorry. I'm not a magician. I'm not a human being. I'm the guy who struggles even to walk. I was there till 10:30 in the night. When I left, eventually escaped through the window. I told him, never call me again. And I'm not going to charge you for the day. It's free because I don't do postmortems. And I walked away, never to look back again. And that's what I learned the hard way. When we get infatuated with technology, everybody suffers. So don't build what you can buy. Don't buy or download what you don't need. And that's basically, again, coming back to parsimony, right? Be minimalistic with what you need and only use what is really essential. So we talked about the reason to do evolution design, some of the approaches to take to do it, discuss the risk of doing it versus not doing it. It's a lot of fun to be doing this, of course, but we have to just get better at it like everything else we do. But here are some of the pointers we can use to get better at this. Keeping it simple, focus on reversibility, parsimony, keep in mind last responsible moment, the Parsons law in terms of how we interface with systems, and be minimalistic. I hope you found that useful. Thank you.
I work with a lot of Node people now, and I have this argument with them all the time. But their counterpoint is that Node actually downloads each library version itself.
That's right.
So